Myself, Ashna K, Department of Integrated Chemistry, MS College, Marampally.
Hi, Joe. Today we discuss an important and an interesting topic in inorganic chemistry, namely metallurgy. Here we discuss how the metals are extracted from its ore in pure form. What do you mean by metallurgy? The term metallurgy is defined as a process that is used for the extraction of metals in the pure form. The extraction depends on the physical and chemical properties of the metal. When these compounds of the metal are mixed with the soil, limestone, sand, and rocks, they are known as minerals. And these metals are commercially extracted from minerals at low cost and minimum effort. And these minerals are known as ores. The modes of occurrence of elements in nature are in two states, namely a native state and a combined state. In the native state, the elements are not attacked by moisture, oxygen, or carbon dioxide. The elements like sulfur, gold, platinum, carbon, noble gases, etc., they exist in their native state. Whereas in the combined state, they exist in the form of carbonates, oxides, and sulfides. We all know that the bauxite is the ore of aluminium and is exists as oxide in the nature. Hematite is the main ore of iron and is existing nature as iron oxide. Whereas zinc blende is the ore of zinc. It exists in nature as sulfide. In metallurgy, the preliminary process are the initial steps that are to be carried out before the actual extraction or refining of metals from ore or raw materials. These processes are crucial in preparing the raw materials for efficient and effective metal extraction or refining. So these preliminary processes helped in reducing the impurities, thereby enhancing the concentration of metals and also optimizing the overall efficiency of the metal. The key preliminary process in metallurgy involves exploration and prospecting, ore identification and characterization, crushing and grinding, size classification and screening, concentration, dewatering, roasting, and calcination, smelting and refining. Smelting, refining and alloying. Exploration involves the systematic search for mineral deposits, and prospecting involves the detailed examination of potential ore bodies. Once an ore deposit is discovered, the samples are collected for laboratory analysis. It involves the mineralogical composition of the ore, chemical composition of the ore, and physical properties of the ore. The ore are often in large, that is, in the bulky forms. So, the crushing and the grinding process are employed in order to reduce the size of the particles. The size classification and screening process ensures the particles of the desired size range sent for further processing while the oversized materials are rejected. Here, the ore is subjected to size classification, screening it into different size fractions. The concentration involves the separation of valuable minerals from the gangue through various methods, namely leaching, gravity separation, magnetic separation, fourth flotation, etc. After concentrating the ore, the slurry may contain excess water. So we must need to remove the excess water content. Dewatering is used for removing the water content from the concentrated ore in order to give a dry transportable material. The roasting and calcination are thermal processes that are used to convert ores and metal compounds into ore into more desirable forms for further processing. Roasting involves the removal of volatile impurities and the sulfur from sulfide ores, whereas calcination involves the conversion of ores and metal compounds into metal oxides. Smelting is the process of extracting metals from their ores by heating them with a reducing agent in order to remove the oxygen. So this results in the crude metal, which is further refined through other process. Refining involves the purification of the crude metal obtained from smelting in order to get high pure metals. The various refining methods involved in metallurgical process are zone refining, distillation, electrolysis, liquefaction, one-acre methods, etc. Alloying is the process of mixing metals or adding other elements in order to get a desired property such as strength, hardness, or corrosion resistance. So these preliminary processes lay the groundwork for efficient and effective metal extraction and refining. So each step plays a vital role in preparing the raw materials or optimizing the metallurgical process, and that leading to the product of high purity metals for various industrial applications. We already say that the ores are obtained in large lumps. That means they are in bulk forms. So ores are usually occur in the form of big lumps, and the lumps are broken into smaller pieces. The process is known as crushing. The smaller pieces are again reduced to in the powder form with the help of ball mill or stamp mill, and that process is known as pulverization. The following figure represents ball mill and the stamp mill. The various steps in metallurgical process. In metallurgy, the main steps involved are concentration of ore, conversion of concentrate to oxide, and refining of metals. The ore can be concentrated in different methods, maybe physical or chemical. Leaching is the chemical method, whereas magnetic separation, hydraulic washing, and froth flotations are physical methods. The ore can be concentrated or can be converted to oxide with the help of roasting and calcination. Calcination involves the reduction of oxide to metal by using some reducing agents, namely heat, carbon, carbon monoxide, etc. Further, refining involves liquefaction, electrolysis, and distillation. How the ore can be concentrated? We already says that the main concentration methods are gravity-based separation, leaching, froth flotation, and magnetic separation. At first, leaching. What do you mean by leaching? Leaching is the crucial process in the realm of metallurgy and hydrometallurgy that to facilitate the extraction of valuable metals from ores and other raw materials. So it involves the use of aqueous solutions to dissolve and recover metals and separating them from the inert gangue or non-valuable components. The principle behind leaching is the dissolution of metals from solid materials into a liquid solution. The aqueous solution is known as leachate and that is brought into contact with the ore or raw material. The leachate may be acidic, alkaline, or that contain other specific reagents tailored to the type of metal and the composition of ore. As the leachate permeates through material, it reacts with the metal, causing them to dissolve into the solution. The leaching can be categorized into three types depending upon the way the leachate contact with the material. They may be heap leaching, tank leaching, in situ leaching. In heap leaching, the crushed or run-off mine ore is stacked in heaps on an impermeable base. And leachate is then applied from the top and percolates through the heap that dissolving the metals as it passes through. The PLS solution is collected at the base of the heap and processed further to recover the metal. PLS means the pregnant leach solution. In tank leaching, it involves the placing the finely ground or in a tank and agitating it with a leachate. So the constant mixing promotes efficient metal dissolution and the pregnant leachate solution is collected for subsequent metal recovery. In situ leaching, this is used when the ore deposit is too deep or too inaccessible for traditional mining. It involves the injection of leachate directly into the ore body underground, allowing the metal dissolution to occur in place. The metal-rich solution is then pumped to the surface for further processing. This figure represents how the alumina is extracted from the ore bauxite. That is, mainly the metal aluminum is extracted from its ore by leaching method. The main applications of leaching involves gold leaching, copper leaching, uranium leaching, nickel, cobalt, and zinc leaching. For gold leaching and copper leaching, both heap leaching and tank leaching are used. For uranium leaching, in situ leaching is used. The main advantages of leaching involves low environmental impact, high metal recovery, selective metal extraction, in situ recovery. Compared to the traditional mining and smelting, the leaching has a lower environmental impact as it eliminates the need for extensive earth moving and reduces greenhouse emissions. It can achieve high metal recovery rates, leading to more efficient utilization of mineral resources. The tailored leaching solutions can selectively dissolve the specific metals and that allowing for the recovery of targeted elements from the complex ores. The in situ leaching provides an opportunity to extract the metal from inaccessible or deep ore bodies without disturbing the surface environment. In magnetic separation, the magnetic separation is the other way of concentrating the ore. The magnetic separation is also a powerful and versatile technique used in mineral processing in order to separate the valuable minerals from unwanted gangue based on their magnetic properties. So, the principle behind this process is that certain minerals are attracted to magnet due to their magnetic susceptibility, whereas the others are not affected by magnetic forces. So it exploits the intrinsic magnetic properties of minerals in order to separate them from the surrounding gangue. The minerals can be classified into three categories based on the response to magnetic field. They may be paramagnetic, ferromagnetic, and diamagnetic. The paramagnetic minerals are weakly attracted to the magnet and are influenced by the magnetic field. However, their magnetic susceptibility is relatively low. For paramagnetic minerals, the magnetic susceptibility is relatively low. Whereas in the case of ferromagnetic minerals, these minerals exhibit strong magnetic properties and also are highly attracted to magnets. So they can be magnetized and maintain their magnetic properties even after the removal of external magnetic field. The diamagnetic minerals are repelled by magnets, but they show magnetic response to the magnetic fields. This figure represents how the magnetic separation process takes place. There are two primary methods of magnetic separation, namely low intensity magnetic separation and high intensity magnetic separation. In the low intensity magnetic separation, it can be used to separate the paramagnetic minerals from the non-magnetic gangue. For this purpose, the ore is passed through a magnetic separator having relatively weak magnetic field. So it allows the paramagnetic minerals to be attracted to the magnetic surface whereas the non-mantle mirrors continue along the trajectory. In high-intensity mantle separation, it is employed to separate the ferromantle minerals from the non-mantle gap. For this purpose, the ore is passed through a mantle separator having high mantle field, that means strong mantle field. And this causes the ferromantle minerals to be strongly attracted, and that can be separated from the non-mantle minerals, that is from the gap.